My name is Lame Wang. I'll introduce the paper submitted to iMeta. The title is Understanding Host Immune Responses in Clostridioides difficile infection, Implications for Pathogenesis and Immunotherapy. Clostridioides difficile, C. difficile, is an anaerobic, gram-positive bacillus capable of sporulation. It thrives in the human gut, particularly following disruptions to the natural colonic microbiota caused by antibiotic usage. This pathogen can cause severe gastrointestinal infections in humans, ranging from mild diarrhea to fulminant colitis and even death. In the United States, it significantly impacts healthcare expenditures. The immune response is pivotal in combating CDI, as the intestinal mucosal immune system serves as the primary defense mechanism against this infection. A comprehensive understanding of the immune response to C. difficile will greatly enhance our ability to effectively manage and prevent disease progression. Highlights: the progression of Clostridioides difficile infection, CDI, is influenced by various factors, including the use of antibiotics, age, comorbidities, immune gene polymorphisms, and antibody levels. Immune response plays a critical role in controlling both the course and severity of CDI. Immunotherapy holds significant promise for advancing both treatment and prevention strategies for CDI. This encompasses the application of monoclonal antibodies, vaccines, and fecal microbiota transplantation, FMT. During CDI, C. difficile induces infection by activating host immune cells. In healthy individuals, left panel, host immune cells and secreted cytokines regulate CDI. However, in individuals experiencing intestinal inflammation, right panel, weakened host immunity leads to increased bacterial exposure, exacerbating inflammation. Prolonged antibiotic usage and intestinal surgeries can disturb the gut microbiota, thus potentially contributing to CDI. Risk factors linked to the advancement of CDI encompass age-related alterations in commensal bacteria, underlying comorbidities, and host genetics. CDI occurs when the C. difficile colonizes the gut and releases toxins that damage the intestinal mucous membrane and actin cytoskeleton, ultimately leading to subsequent apoptosis and tissue damage. Damage to host epithelial cells triggers increased vascular permeability, leading to diarrhea and even colitis. Immune cells play crucial roles in the development, progression, and prevention of CDI. They produce a variety of cytokines, including interferons, IFN-S, tumor necrosis factor, TNF, and ILs, which regulate inflammatory responses and immune reactions. These factors ultimately impact the severity and prognosis of CDI by orchestrating the immune response against the infection. They recruit and activate other immune cells, facilitate bacterial clearance, and modulate inflammatory processes. The gut microbiota plays a protective role against CDI by regulating C. difficile growth through the production of metabolites, antimicrobial peptides, and antibodies. These factors, in turn, modulate the host immune system to combat CDI. The intestinal innate immune system coordinates a diverse array of defensive mechanisms against CDI. Summary: in this study, we highlight the significant role of the host immune response in combating CDI, Clostridioides difficile infection. The immune system regulates inflammatory responses, identifying, eliminating, and preventing infections caused by gut microbiota. In addition, the host immune system promotes the proliferation of beneficial gut bacteria, maintaining intestinal homeostasis and reducing the risk of CDI.